are going to be focusing essentially on one thing only. What is that one thing? Square root stuff, right? Chapter 8 is all about square roots and other various radicals. And so in 8.1, we kind of learned and talked about what they were. In 8.2, we talked about how to simplify them, all the various forms of simplifying them, the Pythagorean theorem, the distance formula. And in 8.3, we're going to talk about adding and subtracting them. And so to kind of help us understand what is going on, I want to compare something that you've done in the past with something new. So if you were to have seen 3x plus 5x, and you're asked to simplify that, what would you say? 8x. Just 8x, right? Let's talk about some of the elements there. In order to get 8x, wouldn't it be fair to say that you guys added the coefficients, the 3 and the 5, and you left the variables, which were the x's, you left those completely the same? Fair to say? Let's take a broader perspective. Why were we allowed to add those two terms together? They're like terms. How do you know that they're like terms? They both have the exact same variable, right? So that makes them like terms, which means we can add them, which means we add the coefficients and leave the variable the same. So the expression on the right over here is really a very similar expression if we think about it like we did with the variables. I would look at these two terms, 3 root 2 and 5 root 2, and I'd ask myself, even though those are not variables, are those like radicals? Aren't they both square roots of 2? Now, if one of them was a square root of 2 and the other one was a square root of 11, then they would not be like radicals, and that would change how we handle this. But because those are like radicals, we can add them as if they are like terms, like we did on the left. And so if you think about what we did with like terms, didn't we take the coefficients, the 3 and the 5, and add them? 3 plus 5 is 8. And then just like we did with the x's over here, we left those x's the same. We are going to leave the root 2's the same as well. So 8 root 2 would be how you could simplify that expression. Just in case you want to prove it to yourself, I'll give you a minute here on your calculators. Go 3 square root of 2 plus 5 square root of 2. Get an answer for that, and then try 8 square root of 2, and you should see that they're the same. So try it. Prove it to yourself real quick, and then we'll move on and try some other stuff. So again, try to prove it to yourself. Let me know if it doesn't work. It should. On that, based on what we just did there, let's try number 1 here together. Number 1 is 4 root 7 plus 6 root 7. So the first thing I'd ask you, the first thing you really should ask yourself is, are those two radicals like radicals? They are. Root 7 is the same as root 7. So whenever you add...
Sorry. Sorry.
Interrupted by whoever that was. So those are like radicals because they are both root 7s. And so whenever you're trying to add like terms up, you add the coefficients, which in this case are the 4 and the 6. So you'd get 10, and you leave the radical the same. So 10 root 7 would be it, would be your simplification there. All right, let's take a look here at the other ones, and we'll get to the board. So numbers 2 and 3, root 10 plus root 6 is number 2. What do you think about that? What?
Not like radicals.
Yeah. So, you could make that little note. You could say they are not like. And so what's your conclusion if they are not like radicals? Leave it. Yeah. It's already as simplified as it's going to, already as simplified as it's going to get. I would say that there is one variation on this that we'll look at here today, maybe tomorrow. Yeah, we'll look at it today. But this one right here, those are just totally unlike radicals. There's really nothing you can do other than just leave them alone. Yeah.
So you wouldn't find the square root of them and add the square root?
With decimals?
Yeah.
You could certainly. But this one just says simplify. And so it's not really asking you to, hey, round to the nearest tenth or whatever. If it did, then that's exactly what you'd do. Yeah. Okay. Last one, let's see how you guys handle this one. 5 root m plus root m minus 9 root m. So the first question you got to ask yourself is, are there any terms in there that are like radicals? Any like terms, essentially? Yeah, there are. Aren't all three of them like? Okay, so you would just combine your exponents, add your exponents up. Does anyone want to volunteer and answer as to what you think this is? Go ahead, Jake.
-4 square root m.
-4 square root m. What do you guys think of that?
No, it's negative.
-3 square root of m. Any other answers?
I say
It's you guys are saying it's either this one or this one.
It's negative 3.
Okay, let's go ahead and analyze, see which one it really is. So when you are adding like terms involving these radicals, we're going to add our coefficients. What is the coefficient on the first term?
5.
Correct. What is the coefficient on the second term?
0.
Not 0, 1. So it's 1 root m. So coefficient there, coefficient on the last one would be -9. So when you go 5 plus 1, you get -9.
Negative 3.
It was -3 root m for your final simplification. Okay. You have any questions? Okay, let's practice this at the board and make sure that you guys are... We had one, I think it was something like, I don't know, it was like root 10 plus root 6. And I said, hey, let's try to add those. And you guys rightfully said they're not like radicals, can't do it, right?
You can add these.
You can. And so here is where we've got to think a little bit deeper. Like with a problem like number 4, I think with number 4, it would be super easy for us to look at number 4 and say, hey, those are definitely not like radicals, and so you can't add them, and so I'm done. But did you notice, as you look at those, did you notice that those radicals have radicands that could be broken down quite a bit? So, you did this on your quiz a little bit ago. And so let's see if we can break these radicals down from 54 and 24 down to lowest terms. We might find that our opinion will change. So, 54, can you guys do the prime factors of 54? Correct. So it would be square root of 3 times 3 times 3 times 2 plus, how about the prime factors of 24?
2, 2, 2, 3.
Correct. So 2 times 2 times 2 times 3. So now as we try to simplify this, remember we're looking for groups of 2, right, to pair off. And so in the first radical I see a pair of 3's that could come out. And so that would end up looking like this. 3 times the square root of 3 times 2, which is 6. And then in the second radical, something similar happens. There's a pair of 2's that get to come out as just a group of 2. So that would be plus 2 square root. And looky there. 2 times 3 is left over. 6. So this ends up being 3 root 6 plus 2 root 6. And now you look at this and you could, I think, rightfully say those are like terms. Those are like radicals. And so we actually can add them. Even though at first it appeared we couldn't, we really can. And so we'd say 3 plus 2 is 5. And we leave the radical alone. 5 root 6 would be our final simplification. Does that make sense? Okay. Something similar here with number 5. Number 5 has variables involved instead of just numbers, but there's a lot of simplifying that can be done here. 147. Can you guys do the prime factors of 147?
Prime.
49.
Yes, 49 times 3. That's right. So this could be simplified as 7 times 3 times t times t. And then this one over here on the right, 48. What are the prime factors of 48?
8 and 6.
Okay.
2, 2, 2. So it's going to be 2, 2, 2, 2, 3.
4 2's and a 3. That's right. So 2 times 2 times 2 times 2 times 3. Okay. So let's see if we can simplify these down. We see the pair of 7's and the pair of t's. So this would end up being 7t root 3. And then over here, I see 2 pairs of 2's. So that would end up being 4t root 3. So again, if you look at that first setup right there, it looks like these are totally unlike terms, right? They really don't look anything alike. But once you simplify them down to their lowest terms, you can see in this case, yes, they are like radicals, therefore they are like terms. If you were to finish this one out, what would you get?
11t radical.
Yep, 11t times the square root of 3 would be exactly right. Okay, so you've had a chance to see this done twice. Would you guys now tackle number 6? We'll go over the answer and we'll finish up at the board. There weren't too many radicals that could be simplified. Let's run through them really quick. Colby, could the first radical be simplified?
Yeah, take out the c squared, just make it 9c.
Yeah, so the first term really is 9c, so that's going to change things a little bit. Hunter, how about the second term? Could that be simplified?
No.
It's already simple as it gets. I agree. So minus 12 root c. It's important to know when you're done, right?
Yeah.
Instead of doing things you shouldn't be doing. Amelia, how about the third term? Is that simplified or not? Yeah, it is. Nothing we can do there to simplify that further. 5c, I think likewise is all the way simplified. But what about that last one? Danny, what do you think with root 4c?
It'd be negative 2
2 what?
radical C.
Radical c. Okay, I agree with you. So it appeared that there were some unlike terms in there, and I think now that we've simplified everything, we can still see that there are unlike terms, but there are some like terms, maybe more than we thought. Rocky, what is like 9c?
5C.
All right. Thank you, Rocky. You are right. 14c. Ellie, what in the world would we pair up with negative 12c?
Negative 2C.
Or did I say c? I meant to say root c. Negative 12 root c. You said negative 2 root c?
Yeah.
What about that 8 root c? Is that also like those two?
Yes, they have an 8 roots.
So when you combine those, what did you get?
I got negative 6 roots.
That is exactly right. Nicely done. Okay, do you have any questions? You all had a chance to do that one by yourselves? Success?
Yeah.
Success. All right, go to the board. We got about 5 minutes left. Let's see who wins today.